Now this lesson looks at perpendicular lines, revision of GCSE again. What we have is we know that if we have one gradient which is positive, the other gradient will be negative, positive gradient, the other one will be negative, and vice versa. And we know if they're perpendicular to one another, one of the gradients will be the reciprocal of the other. So if that was a gradient of 2, that will have a gradient of a half, but it'll be minus a half. Also worth noting that if I took this numerical value across the other side, it becomes a times, which gives me m1 times m2, i.e. the two gradients multiplied together is equal to minus 1. So that does sometimes come into play, but for the best part of questions, it's that knowledge, as it was with GCSE, that you need to know. So putting this perpendicular into practice, we've got 2 points here. If I put them on a set of axes, at minus 2 we're up at 1. At 4 we're at minus 7. And we've been asked for the perpendicular bisector of AB, so we need the midpoint, which we learnt on the last lesson, and we therefore also need the perpendicular knowledge, because at the end of the day, it's that line that I want to work out. First of all, the midpoint. So the midpoint, minus 2, add 4 is 2, half of which is 1. 1 add minus 7 is minus 6, half of which is minus 3. So that's that coordinate there. To establish this gradient, I have to work out this gradient first. So the gradient of AB is equal to the difference going down here is negative 8, 1 unit and 7 units. Going across, we're going to cross 6, and we can cancel that down because equivalent fractions, we can half that and half that. I'll leave it like that, because then the gradient of our line, the perpendicular gradient, will be the reciprocal of that, and that's minus, so that'll be plus. So therefore, now for the line, y minus minus 3 is equal to the gradient x minus the x coordinate 1. As in previous, set that across the other side as a times. So 4y plus 12. That 4's gone now, so 3 times x is 3x minus 3. And all I have to do is take the 12 across, minus 12, so minus 15, and that'll do. That's the equation of that perpendicular bisector. Now this example here makes use of the m1 times m2 equals minus 1. Again, drawing a sketch is helpful. So at minus 2, we're at minus 1, that's A. At minus 7, we're up at 4, that's B. And at minus 1, we're up at 1, that's C. And if we join those up, then one of those is a right angle, which looks like it could well be that. So we would need to find the gradient of BC and the gradient of AC. So the gradient of BC, I can see, is negative. And from the 4 to the 1, I've gone down 3. And from the minus 7 to the minus 1, I've gone across 6. So that gradient is minus 1/2. As for the gradient of AC, it's a positive gradient. From the minus 1 to the 1, we've gone up 2 units. And from the minus 2 to the minus 1, we've gone across 1 unit. So that gradient is 2. So the gradient of AC times by the gradient of BC is 2 times minus 1/2, which equals minus 1. Therefore, perpendicular, which means that that is a right angle triangle. Now, I don't want to lose sight of the fact that y equals mx plus c is still useful for certain questions. So a question down here, we've been given one coordinate and we've been given a setup which I can easily rearrange as 2y equals 7 take 3x. So y is equal to 7 over 2 or 3.5 take 3 over 2 or 1.5x. So the gradient of that line is minus 3 over 2. Now if we've got a line which is parallel, I'll want it to have the same gradient. So we've got y minus 3, because our coordinate is 3 for the y, is equal to the gradient x minus minus 4, so plus 4. As with the previous, set the 2 across becomes times 2. That means we've got minus 3x minus 12. And if we take all this across to the side, a bit like what we've got there, then we have that 2y plus 3x and minus 12 becomes plus 12, so we end up with plus 6 equals 0. Similar to the last question, we first of all need to establish what the gradient of this line is. So 3y is equal to x minus 1, moving the x and the 1 to the other side. So y is equal to, divide by 3, we end up with 1/3 x, x divided by 3, which is 1/3 x, take 1/3. So the gradient of this line is 1/3. That means that the perpendicular gradient will be the reciprocal of that, which is 3. That was a positive gradient, so our gradient is negative. Now putting that into our structure, we know that the y coordinate is a 3. We've just established that the gradient is minus 3, and we've got x minus 1. So y minus 3 is equal to minus 3x minus 3 times minus 1 plus 3. Careful with your minus signs. Again, I'd be inclined to bring that across to the other side as a plus 3x, y plus 3x, and I do have choice. I can bring that 3 across, which I will do, and I've got minus 6 equals 0, but equally so, I could bring that across and have the 6 over here. Choice. There's your answer.